Hello everyone, welcome back to the session. So today's class we are going to learn how to add two vectors. Okay, so before we begin the class, my name is Mohana. I'm a physics educator here at Unacademy. I have a master's degree in physics and I'm also a plus verified educator. Now if you can follow me through my Telegram channel, so this is the link. And this is the common ICSE and ISE board Telegram channel, so you can follow this channel as well. And let's begin today's session. So what happens, let's say for example, let's say there are two vectors. Okay, let's say we have a marble. Okay, now let's say we give two different velocities to this particular marble. For example, let's say you and your friend hit this particular marble. Okay, your friend hits it from this direction, so a velocity was given to it through this direction, and let's say you are hitting it through this particular direction. Both of you ended up hitting this marble over here. Okay, so two different velocities are given. So we know velocity is a vector, so this is basically, let's call this as A vector, okay, and B vector. Now how would the resultant be? That is, you add these two vectors, right? Now the process by which you can add these two vectors, that is basically called as addition, or in other words composition of vectors. Okay, so the word composition means addition. Okay, we are adding two vectors. Now if you add these two vectors, where the resultant would be, like the effect of these two vectors, okay, that is basically called as the resultant vector. Now the resultant of two or more vector is nothing but that single vector that is producing the same effect as the individual vectors when they are added together would produce. So there are two words, one is composition. The word composition means the process of adding two or more vectors. Okay, resultant, when you see, if you add two or more vectors, what is the final vector you're getting? That we call it as the resultant vector. Okay, now this is about addition, and these two terms you will actually repeatedly see, right? Now you cannot add vectors like how we could so basically to add vectors we are going to make use of trigonometry. Okay, so we cannot just add vectors normally, so we have to make use of the vector laws available. So there are three vector laws. One is triangular law of vector addition, another is parallelogram law of vector addition, and finally we have polygonal law of vector addition. The first two cases you have over here, right, that is triangle and polygonal. This is basically to add only up to two vectors. If you are adding more than two vectors, then we go with polygonal law. Okay, alright. Now triangle law is very simple. Okay, now let's say there are two vectors. Okay, for example, let's say we have a ball. Now you kick the ball. Okay, so you have displacement is a vector, right? As you kick the ball, let's say the ball ended up over here. So this was initial displacement. Let's say your friend over here kicks the ball and it ended up over here. So this is the second displacement given over here, right? So there are two different vectors over here. We have to add the two different vectors and say where the final vectors is. So first displacement vector we have, let's call it as A vector, and the second displacement vector we have, let's call it as B vector. Where is it finally? Where is the ball finally at? Okay, now from its initial position to the final position, if you connect, that gives you the final resultant vector. Okay, so what triangular law of vector addition says is, if you end up taking, okay, two sides of a triangle, if you end up taking two sides of a triangle as if you take two sides of the triangle, right, for the particularly the individual vectors A and B vectors, then the final resultant vector that you have will be given by the third side of the triangle. So this resultant vector is nothing but adding A vector plus B vector. So basically this length of the vector tells you what is the magnitude. For example, let's say this particular final displacement vector is somewhere around 10 meters, and let's say this is somewhere around due northeast. Okay, so this R vector, the length of the vector will basically tell you what is the magnitude, that is the 10 meters, and from the initial vector A vector over here, let's take an angle beta. So from the initial vector A, if you go about a degree beta over here, that would end up giving you the final resultant vector. Okay, so this gives you both, this gives you the third side over here of the triangle, gives you both the magnitude and and direction of the vector. So this is basically triangular law of vector addition. Now parallelogram law of vector addition is much more simpler. Now you take these two vectors, okay, let's say A vector as one side of the triangle and B vector as another side of this parallelogram over here. Then the diagonal over here, the diagonal gives you the resultant R vector. Okay, now vector, if you see, vector addition is commutative and as well as associative. So this side A we have, right, this side length that we have over here, if this is A, now opposite side, this is also A, and this side over here, this is also, this side we have, this side of the parallelogram also is equal to the vector B. Okay, so this is basically parallelogram law of vector addition. That is, if two vectors can be represented both in magnitude as well as direction as two adjacent sides of the parallelogram and they are drawn from the common point. So that's the difference between your parallelogram and triangular laws over here. Triangle law, you have a vector, the second vector starts from the head of the first vector. But in parallelogram law, if you see, both the vectors, okay, starts from a single point. Now, then if you see the resultant vector, you can represent it completely both magnitude wise and direction wise, okay, by the diagonal passing through this parallelogram. Okay, this is parallelogram law of vector addition. The next one what we have is the polygonal law of vector addition. For example, let's say polygonal, the word itself means many side, right? So for example, let's say there are four vectors, okay, let's say we have a vector, okay, and let's say we have about a vector, and let's say we have another vector B vector over here, and let's say we have another vector C vector, and finally we have another vector D vector. Now these vectors, what you can do, you can take them one next to another. So this is A vector, means from the head of A vector you can start B vector, okay, from the head of B vector you can actually start C vector, from C you can end up giving the D vector. Now if you see, where is the initial vector? Think of where the initial vector is, that is over here, and the final vector. If you join these two, you will get the resultant R vector. So this R vector is nothing but A vector plus B vector plus C vector plus D vector. So here when you are talking about polygonal law of vector addition, okay, this is for adding more than two vectors. So if a number of vectors are represented both in magnitude and direction by the sides of an open polygonal taken in the same order, okay, we took like A, B, C, D, we left it the same order over here, then the resultant over here can be represented both in magnitude and direction by the closing side of the polygonal taken in opposite order. Okay, so this is these are the three laws. Now we'll see, when we just have two vectors, how we can use triangular law of vector addition to find the resultants, magnitude and direction. So whenever you talk about a vector has a magnitude and it has a direction. We have to find both. Okay, so let's go with this one. Let's say this is basically triangular laws, right? So let's name the side of the triangle. Let's say this is O. Let's say this is P. Okay, now this OP side over here, let's say this represents A vector. Okay, now let's say this side over here is Q. Now this PQ side, let's say there is another vector which is basically B vector over here. Okay, now the resultant R vector is given by OQ. The R vector is nothing but A vector. It's an addition of A vector P plus B vector. So we want to find the result, we want to find the magnitude of this R vector as well as the direction. So how can we give the direction? Very simple. From A, if you go an angle towards R, if you draw the angle between this A and beta to R over here, okay, you end up getting beta. So if you find beta over here, that gives you the direction. That is, from the A vector, how many degrees you need to move to find the direction of the resultant. Okay, now very simple. Now to find the magnitude, all we are going to do is basic trigonometry. Okay, so from this point Q over here, we are going to drop a perpendicular. Okay, now let's say we drop a perpendicular and this is N. Now what we have is this side over here, this is 90 degrees. So but we don't know what this angle is. Let's take it as theta. Okay, good evening Akshay. And what we have is a right angle triangle now. Okay, what we have is a right angle triangle. Okay, now certain things we can say from here, that is this angle QPN is equal to theta. Okay, we know this angle is theta. then the side of the triangle OP, right? This side, this length is equal to the magnitude of the A vector, okay, and this length PQ is equal to magnitude of B vector. Okay, now from here we are going to do a very simple thing. All we are going to do is, first we are going to consider this right angle triangle. That's all. Okay, let me mark this. We are just going to consider this right angle triangle, and let's take sine and cos value. Alright, now very simple. What will be sine theta? In this case, if you take very simple, sine of the angle theta. Sine is basically opposite by hypotenuse, right, or perpendicular by hypotenuse. Perpendicular is this side over here. That is, if we say take sine, we have, that is nothing but Qn by PQ, right? So now we have Qn by the other side, we have PQ, right? Yes, yes, actually, thank you for that. Now sine theta, if you take, okay, one side we have Qn, then the other side PQ. PQ, what is the length of this side? This is nothing but B. Okay, so first thing that we have gotten is, from here, from this equation, if you see what is Qn, that is nothing but, this Qn is nothing but equal to B into sine theta. Okay, so let me write this separately. First we know this Qn that we have over here, this is nothing but B sine theta. So this side length over here is nothing but B sine theta. Okay, now this is Qn. So let me write this, Qn over here is B sine theta. Now let's do the next one. Okay, let's find what is, we found the sine, let's try and find what is cos. Okay, now cos of theta, very simple over here. If you take cos theta over here, okay, cos of this angle theta over here, cos theta is nothing but adjacent by hypotenuse, or in other words base by hypotenuse. Base over here is what? Base is nothing but Pn, okay, and by PQ. Hypotenuse is PQ, right? So we have Pn by PQ over here. Okay, now thank you for that, Akshay. Again over here, what is PQ? PQ side length is B. So from here, if you see what is Pn over here, that is nothing but you cross multiply, you get B cos theta. Okay, Pn over here is nothing but B cos theta. So this side length is nothing but B cos theta. So that is this side length. Okay, and this is B sine theta. Alright, okay. Now we have gotten some values. Now if you overall look at it, this particular triangle, okay, earlier, compared to the earlier case, okay, what we now have is basically a right angle triangle, right? Let's just look at this. Okay, what we now have is a right angle triangle, that is basically we have the triangle O, okay, O and Q. We have a right angle triangle. Now for this particular O and Q, we know what is this side length. This side length is A plus B cos theta, and this side length also we know this is nothing but B sine theta. Obviously, if we know these two, we can find the hypotenuse. What is the value, magnitude of the hypotenuse, for which we are going to make use of Pythagoras theorem. Okay, so if you use Pythagoras theorem here, what would you get? Okay, so we have the triangle. Alright, let me just quickly write. We have the triangle O and Q. Sorry, a right angle triangle. We have the right angle triangle O and Q. Okay, to this right angle triangle O and Q, okay, if you apply Pythagoras theorem, what would you get? If you see, that is hypotenuse, that is OQ square. This is nothing but, okay, OQ square is nothing but equal to ON square, okay, plus QN square. Okay, now what is OQ square? Okay, OQ square is nothing but R square. Okay, this side length over here, its magnitude is equal to R. Okay, now if you look at ON, right, ON is nothing but, okay, ON is nothing but, it is basically OP, right, this side length OP plus PN, okay, plus PN the whole square, plus we have QN square. So if I substitute, I get r square is equal to what do we have here? OP, right? OP is nothing but OP in this case is nothing but, we know this side, this length over here is nothing but equal to A, right? So this is nothing but A plus Pn, we just found Pn is nothing but B cos theta the whole square, okay, plus what is Qn? Qn is nothing but that will be B sin theta the whole square. Okay, so let's just solve this equation. Let me write it down separately and let's just solve the equation. Okay, what do we have right now? We saw r square is equal to, we got A plus B cos theta the whole square plus B sin theta the whole square. Now this is of the form A plus B the whole square. So we can expand it, right? So we can expand this one. So what we have over here, first we have r square, this is equal to, this is A square, and this term over here is B, okay, B cos theta the whole square plus, right? Thank you Akshay for that, 2AB cos theta, okay, plus then we have the next term is nothing but, okay, B sin theta the whole square, right, which we can write it as B square sin square theta. Okay, and here again we have B cos theta, which we can write over here as B square sin square theta. Now let's bring A square to one side, okay, and okay, now we have two terms, B square sin theta, B square cos theta, right? So let's take that separately, okay. Now we have 2AB cos theta plus then we have B square. In both these terms we can take B square separately, then you will end up having cos square theta plus sin square theta, right? So this is nothing but B square cos theta and B square sin theta, okay. We have taken the term B commonly out and we have cos square and sin square theta. Now we know this, cos square and sin square theta is what? What is the value of cos square and sin square theta? Cos square and sin square theta is nothing but this value is 1, right? So from here what is r square over here? Okay, r square is nothing but A square plus B square plus 2AB cos theta. Now one more thing we just have to do, very simple. What will be r? We know r square. What will be r? That will be root of A square plus B square 2AB cos theta. This gives us the magnitude, this equation gives us the magnitude of r vector. That is, when you add two vectors, you just substitute the square the magnitude of one vector, both the vectors, okay. Apply this formula to find the resultant r vector. This gives you the magnitude, okay. Now we have found the magnitude. What we want to end up finding is, now that we know what is the magnitude, we want to find what is the direction, okay. For finding the direction, again as I said earlier, we have a right angle triangle over here. So if I want to find the direction, which is the addition of, so this vector B vector over here is resolved into two components, that is B cos theta and B sin theta, okay. So this length is A and this length is B cos theta and this is B sin theta. So this side, okay, the base and the height and the perpendicular of this triangle gives us the total A and B theta, A and B vector together, okay. So we have beta over here, we want to find the resultant, okay. So if you take for this triangle, if you take tan beta, okay, so for this triangle if you end up taking tan beta, so very simple in this case, if you take tan of beta for this particular triangle, then what we have, tan beta is nothing but equal to, tan beta is what? Again it will be opposite by adjacent, right? What is opposite? On the opposite side we have Qn, right? On the opposite side we have Qn by the adjacent side, sorry, the base side over here, yeah, the adjacent of the base side, we have OP plus or the total length we can say it as ON. Yes Akshay, thank you for that. We can say the whole length is ON, and we know this is QN, and we know what is ON over here, right? ON over here, sorry about that, ON over here is nothing but OP plus PQ, right? So this will be nothing but OP plus PN, right? OP plus PN. So that's it. Just substitute the values in this. Tan beta will be Qn. What is Qn over here? Qn is nothing but this side is B sine theta divided by OP. OP is basically nothing but this length over here. OP is A and Pn is B cos theta, right? So OP over here will end up being B plus Pn is basically, OP is, I'm really sorry guys, this OP is basically A, right? That side is basically A, and Pn over here is nothing but B cos theta. That's it. We got tan beta. From here we can find beta. Beta will be tan inverse of B sin theta, okay, divided by A plus B cos theta. So you can find this quantity. You can find the beta if you just know this angle theta, and if you know what is B cos theta and B sin theta, and if you know what is the value of A, magnitude of A, then you can find beta. So beta will again be in degrees. So from the A vectors, how many degrees you need to move to get the direction of R. Okay, that's how you find the resultant. So what we have done in today's class is we have used just triangular law to find the magnitude of the vectors. That is, when you add two vectors, what is the magnitude? Magnitude is nothing but if you take a vector, the length of the vector gives us the magnitude. Okay, to find the magnitude we use this equation. Okay, so that will be root of A square plus B square plus 2AB cos theta. Okay, now this angle between A and the resultant R is actually beta. Now if you want to find the direction of the resultant R, okay, then we use this formula, tan beta is equal to B sin theta plus A plus B cos theta. Okay, so this is how we find the resultant. Okay, the resultant vector's magnitude as well as direction. Now there are few special cases. For example, what if both the vectors are in the same direction? Okay, one thing we know is we know that R vector is nothing but root of A square plus B square plus 2AB cos theta. If both vectors, A vectors as well as B vector, are in the same direction, means, okay, angle between them is, okay, if angle between them ends up becoming 0, means, then, okay, then R vector will be what? Okay, then R vector will end up becoming, okay, really sorry guys, just a second. Okay, then R vector cos 0 is 1. Okay, so this will end up becoming A square plus B square plus 2AB, which is nothing but R will be root of A plus B the whole square, which means R will become just, okay, A plus B. So if you have two vectors that is going in the same direction, if you have two parallel vectors, then the final vector you will end up getting would be the sum of these two vectors. Obviously, what will be the direction of the vector? That will be in the direction of the individual vectors. What is the direction of both the individual vectors? The final vector will be in the same direction. Okay, next what we are going to see is analytical method of vector addition. But in this case, the second special case is what if both the vectors are in opposite direction? Okay, so once again we have a vector where the direction of them are opposite to each other, right? So we have one vector A vector and another vector B vector in opposite direction. So what we see over here, we have, if they are opposite to each other, if there are two vectors that are opposite to each other, then angle between them, okay, theta becomes 180 degrees. Okay, now if you take R, this is nothing but root of A square plus B square plus 2AB cos 180 degrees. Now cos 180 degree is nothing but minus 1. Okay, cos 180 degree is nothing but minus 1. So we will have A square plus B square plus, okay, so sorry, this will become minus, right? This will end up becoming minus 2AB minus 2AB. I'm really sorry, because cos 180 becomes minus 1. So this is nothing but R will be root of A minus B the whole square. So R will be A minus B. Okay, so if we have two vectors that are in the opposite direction, then okay, that are going in or two mutually opposite direction, the resultant will be the difference between these two vectors. Obviously, what will be the direction? Look at the length of the vector. Okay, whichever magnitude, which of these two vectors has a bigger magnitude, that is, look at the length of the vector. Length gives you the magnitude of the vector, right? So here, if A vectors is bigger, means so the final resultant will be along A vector. Okay, so for example, let's say this is A vector, and for example, let's say this is B vector, then the resultant will be along the direction of B vector. The magnitude of individual vector, whichever has the biggest magnitude, that determines the direction of the final vector. There is one more case. What if they are perpendicular to each other? Okay, in this case, what will happen is very simple. See, look at this equation. This equation is nothing but we have plus 2ab cos theta, right? But angle over here is what? Angle over here is 90 degrees. If this is 90 degrees, if angle over here is 90 degrees, then this cos 90 will become 0. So this term plus 2ab becomes 0. If this plus term 2ab becomes 0, all you will have is a square plus b square. That's it. So the resultant is just square of the other two vectors. Okay, square the sum of the square of other two vectors and take a square root of them. Now, what will be the direction? Okay. Now, again, for you to find the final direction, if you see, very simple quantity again. So, we know tan beta is nothing but equal to b sin theta, okay, divided by a plus b cos theta. Here, what we are saying, theta is equal to 90 degrees. When you say tan sin 90, okay, so we know sin 90 is nothing but sin 90 degrees is nothing but 1. But cos 90 degrees is basically 0. So, b into sin 90 is 1. Okay, this is into 1. Now, we have a plus b into cos 90 is 0. So, tan beta over here will end up becoming b by a. Okay, because this term will end up becoming 0. So, all you will have is b by a. Okay, so beta will be tan inverse of b by a. That's it. So for the final resultant, if you want to find, you just have to take tan inverse of b and a, the length of b and a. Okay, this will give you the final vector. Alright, with this note, we are coming towards the end of today's class. So if you like the class, please share it among with your friends. Do subscribe to the channel, and we also have the ICSE and ISE master channel, so subscribe to that channel as well and click on the bell icon, so before any classes goes live you will get the notification. Now on the platform also we have a number of free classes, so there would be description links below. Okay, so just in the description box there would be links to those classes, so just go to the platform and you can actually enroll for those free classes as well. Okay, see you again in another class. Bye. Thank you.